Okay, just a bit of an introduction to this AVO Mk2. There were a couple of, as far as I can tell, there were a couple of different Mark IIs that were built between 1952 and 1956. And then from the end of 1956, they started building the Mark III and so on. So the earlier Mark IIs did not have these handles on the front of the unit. I guess they're there to help lift it up, but also to protect the face of the instrument, protect the dials and the meter, when you're packing it, moving it. The other little difference is that the earlier Mark IIs, to help hold the lid in the vertical position when you're testing the valves, they had these little brackets on the side here to help keep it vertical. This one has these little rubber grommets instead. Okay. So the other interesting thing that I read is that I read somewhere that the serial number that's on the meter, the last three numbers are supposed to indicate the date that the unit was built, and that U is an export model. Okay, well, according to that, then this would be June 1954, and because this unit has been in Australia for many, many years, I guess that's an export model. However, with these Mark IIs, the serial number, there's a serial number on the sticker on the top right-hand corner of the machine. And that serial number is repeated. If you look at the valve testing manual that came with it, that serial number is also indicated on this card. There it is there, 5783. Now what this pin card was for was that you'd tear these cards out and you'd send them into AVO, and then they would send you updates for the valve data. This particular model, amendments number 1 and 2, as you can see, already are incorporated in the manual. But the interesting bit is that they kept track by stamping the number that was on the front of the machine on the cards, right? So I tend to think that that is the serial number of the machine. And because that serial number there is different, I guess, and the lower number, I guess that would be for the number for when the meter was made. Going by that, this machine might have been built between 54 and 55. I'm just hazarding a guess here. I don't know. Okay, so going on, the rollers on the machine on the top, there's 9 different selectors or rollers, and each of them has a set of numbers, right? You can set them individually, 7, 4, 1, so on. They select the electrodes that go to the pin numbers on the valve, right? So at the moment I've got that set up for a 12AX7. Now how that works, I've made a little card that shows how that works. So each selector, now 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0, each selector can be set, like if you select number 1, there'll be the cathode. Select number 2, there'll be heater. Number 3, heater plus. Number 4, the grid. Number 5, screen, etc. Okay, so that's these rollers here. Now if you look at a 12AX7, right? So the 12AX7 has 2 triodes, and that's what the T indicates. So that's triode number 2, and you've got T1. That's triode number 1, right? Now if you look at how the selectors are set, I've got them set for a 12AX7. So if you look at valve pin number 1, which is there, that's set to number 7, which is anode 2. Now if you look at the valve, you can see that pin number 1 is set to plate for triode 2. So what we're setting is anode 2. That's what that number is, right? So if you look back at the selectors, there you go, 7, anode 2. And so you can set the selectors following the valve pins. And if you don't have the data manual, if you look at the data manual, so for a 12AX7, right, 741226413, which is what I've got this currently set to, 741226413, right? So if you don't have the valve manual, you can still set a valve by referring to the data sheet, the valves data sheet, finding out what the pinouts are, reproducing them here. Okay, so they'll set up the valve for a test. All right. The rest of the dials, they help you to set the valve for testing. So if we look at, say, let's have a look at a 12AX7, it tells you that you should set the filament to 6 volts, the negative grid volts to 2, the anode volts to 250. There's no screen volts. And then these would be the results for a good valve. So what you'd expect to find on a good valve. Okay, so if we go back to the machine and we start with filament. So the filament, we set it to 6 for the 12AX7. We'll leave that on 0. So this dial is if you have valves that have higher filament voltage, then this dial allows you can add this. So we only got 6 volts, so we leave it on 0, right? We go on to the negative grid volts. We set that to 2. Now the negative grid volts has a multiplier. So if you have a valve with that draws 14 or 20 negative grid volts, so you set that to 2 and set that to 10. That would give you 20. But in this case, for the 12AX7, leave that at 1, right? The plate volts, we set to 250 as per the book. There's no screen, so it doesn't matter where this dial is. And because the 12AX7 has 2 triodes, we can test anode 1 and anode 2 just by doing that. Okay. So we turned the machine on. And as you can see, the Mk2s, the AVO's Mk2s, had a rear lit meter, whereas the Mk3, Mk4s, they didn't have a rear lit meter like this. So that's another difference between the Mk2s and the ones that followed. Right. So now the machine is on. To calibrate the machine, we have a look at where the needle is, and the needle needs to be within that little black square and near as possible to that red line. So if your voltage is not right, let's say it's there, you need to adjust it by adjusting this dial so that we're within that little black square and as near as possible to that little red mark. Okay, so you're basically calibrating the machine, the voltage of the machine, before you test the valve. Okay, the next thing we've got to do is the meter selector. This dial you can select which scale on the dial we're going to read from. Now it gives you 3 scales, although there's only 2 here, but I'll explain that. If you set the meter selector to 100, what the meter indicates is that you've got 100 millimeters being read on that scale. So that is exactly that, 10, 20, 30, and so on till 100. If you set the meter to 25, then you're reading the lower scale, 0, 5, 10, 15, 20, 25. If you select it to 10, if you select 10, then what's happening is that 100 becomes 10. So then that scale becomes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? if we select 2.5, that scale becomes 2.5. That's 2. That's 1.5. 1.5. Okay. The lower coloured scale, we got replace, the middle bit, and good. That's where when you're looking at the quality of the valve, okay, you set that to milliamps per volt, and at the same time you set this dial to the expected transconductance of the valve, right? So for a 12AX7, the expected value is 1.6. Have a look at the book. Where are we? 1.6. Okay. So we initially set that to 1.6 when we're doing the quality test, and that's where this colored scale comes in. So you'll have good, intermediate, and maybe replace the valve if it falls into that red area. So that's that explained. Okay. I will switch that back to 100. It's always advisable to have it, to leave this set to the larger scale, because it prevents, in case there's a bit of an accident when you're testing the valve, it prevents the dial from getting damaged because it's too sensitive. Okay. Right, so moving on. The set 0, or what they call the backing off, when you're going through and doing a test on the current draw of the valve, right, that needs to remain in this position, fully anti-clockwise. After you've done the test for current draw, you will do then the test for mutual conductance. And in that case, we need to back off the needle to 0 so that we can conduct a mutual conductance test. I'll show you that when I do a test on a 12AX7, so you understand what that's all about. But we always set the set 0 dial to fully anti-clockwise. Now this electrode leakage or shorts works in conjunction with this dial. So normally when we start off, we check the valve cold. So that means that although the valve is on the socket, we're actually not putting any heater voltage through it, right? So that the valve is cold, so the valve is inert. So we're basically just checking to see whether all the parts, all the triodes, the bits and pieces within the triode or the valve are not shorting between each other, right? So check cold. So we check to see that the filament is working, that there is no shorts on the cathode, the grid, the screen, anode 1 and anode 2, right? So then after we've done that, when we're sure that there's no shorts on the valve, we'll check it hot. Now when we check the valve, so we've already checked there's no shorts on the valve. So when we check for other shorts when the valve is hot, we only need to select check hot or check H, and it'll do the rest. It'll test the rest of the valve. We then, if that's all okay, we then continue to check whether there is a short between the cathode and the filament when the filament is hot, because it might expand a little bit and might touch the cathode. And if that checks out okay, well, then we can go to test the valve. Okay. I'll put that back to there. How's that voltage going? Good. Set pretty good. Okay. Now these three buttons here, what they do, this one checks for gas in the valve. Basically, it checks that the current draw within the grid current is not excessive, because if it is, there's a good chance that there's gas within the valve, right? The reset button, what that does, now sometimes when you've gone through all the shorts, but sometimes when you're testing a valve, let's say it's a 6L6 or an EL34, and there's a surge of current draw on it, the machine will turn off sometimes. And that's basically to protect the machine, which is a good thing, right? So what you need to do is pull the valve out, reset it, the dial will turn back on, and you test it again to see if there's an issue with the valve, all right? This particular button, the milliamps per volt, that will give you a value on the meter on either of these scales of the actual value of the transconductance of the valve after you've done the current draw test. Okay, so the procedure is, after you do the current draw test, right, you then back off. So the current, the current will be indicated, the needle will be, say, somewhere there. You back the needle off so that the needle points to 0, and then you press the transconductance button, and that'll give you an indication of the value of the transconductance. That's how that works. Okay. That's about it. The other thing is, whoops, switch that off. So this machine, what it has like a chassis inside where all the internals are connected to, and this is basically just a cover that you can actually pull off. You take these bolts out on either side, handle comes off, right? And then you can pull the whole cover off, which makes it quite easy to maintain and do a little bit of work on the machine. Now this machine in particular is, amazingly enough, I mean, we're talking about what, a 70-year-old machine from 1955. I'm doing this in 2026, so you're looking at a 70-year-old machine. Internally, it's pretty much in original order, except that I've changed the electrolytics a couple of times, or an electrolytic. which is normal, not a big deal. Okay, so that's the introduction to this AVO Mk2. I'll do another video, which will be part 2 to this, where I'll go through testing a 12AX7. Okay.